nicotine, vaped, smoked, dipped, or snuffed, or these little Zyn pouches, or taken in capsule form, does improve cognitive performance. I'm not suggesting people run out and start doing any of those things. I did a whole episode on nicotine. The delivery device often will kill you some other way or is bad for you, but it causes vasoconstriction, which is also not good for certain people. But nicotine is cognitive enhancing. Why? Well, you have a couple sites in the brain, namely in the basal forebrain, nucleus bassalis, in the back of the brain, structures like locus ceruleus, but also this, what's called, it's got a funny name, the pedunculopontine nucleus, which is this nucleus in the pons, in the back of the brain, in the brainstem, that sends those little axon wires into the thalamus. The thalamus is a gateway for sensory information. And in the thalamus, the visual information, the auditory information, it has nicotinic receptors. And when the pedunculopontine nucleus releases nicotine, or when you ingest nicotine, what it does is it increases the signal to noise of information coming in through your senses. So the fidelity of the signal that gets up to your cortex, which is your conscious perception of those senses, is increased.
And how much endogenous nicotine do we produce?
Well, it's going to be acetylcholine binding to nicotinic receptors.
I see. We're not making nicotine.
Right,
we're just binding.
Nicotine.
So this is a nicotinic acetylcholine receptor.
Right, of which there are at least 7 and probably like 14 subtypes. But right, they're called nicotinic receptors in an annoying way, in the same way that cannabinoid receptors are called cannabinoid receptors. But then everyone thinks, oh, those receptors are there because we're supposed to smoke pot, or those receptors are there because we're supposed to ingest nicotine. No, the drugs that were used to study the receptor. That's right. Yeah. Right, exactly. Receptor is named after the drug. And so the important thing to know is that whether or not it's basal forebrain or pedunculopontine nucleus or locus ceruleus, that at least in the brain, because we're not talking about muscle where acetylcholine does something else via nicotinic receptors, there, in general, it just tends to be a signal to noise enhancer. And so for the non-engineering types out there, no problem. Signal to noise, just imagine I'm talking right now and there's a lot of static in the background. There are 2 ways for you to be able to hear me more clearly. We can reduce the static, or I can increase the fidelity, the volume and the clarity of what I'm saying, okay? For instance, and that's really what acetylcholine does. That's why when people smoke a cigarette, they get that boost of nicotine and they just feel clearer. It really works. The other thing that happens is the thalamus sends information to a couple of places. First of all, it sends information to the reward centers of the brain, the mesolimbic reward pathway that releases dopamine. And typically when nicotine is increased in our system, dopamine goes up. That's one of the reasons why nicotine is reinforcing. We just like it. We seek it out. I've done beautiful experiments with honeybees even where, you put nicotine on certain plants, or it comes from certain plants and they'll forage there more. You get, them kind of like buzzed. That was a pun, bad pun. In any event, there's also an output from this thing, the thalamus, to the ventromedial prefrontal cortex, which is an area of the forebrain that really allows us to limit our focus and our attention for sake of learning. It allows us to pay attention. This is the circuit.
You talked about this in your fantastic podcast on stimulants.
Yeah, on ADHD. Yeah. So ADHD, typically ADHD drugs. So things like Adderall, Vyvanse, methamphetamine for that matter, Ritalin.
Yeah, why it's counterintuitive that a stimulant would be a treatment for someone with difficulty focusing.
Yeah, in young kids who have difficulty focusing, if you give them something they love, they're like a laser. And the reason is that ventromedial prefrontal cortex circuit engages when the kid is interested and engaged. But kids with ADD, ADHD tend to have a hard time engaging their mind for other types of tasks, and other types of tasks are important for getting through life. And it turns out that giving those stimulant drugs in many cases can enhance the function of that circuit, and it can strengthen so that ideally the kids don't need the drugs in the long run, although that's not often the way that it plays out. And there are other ways to get at this. There's now a big battle out there. Is ADHD real? Is it not real? Of course it's real. Does every kid need ADHD meds? No. Are there other things like nutrition, more playtime outside, et cetera, that can help improve their symptoms without drugs? Yes. Is the combination of all those things together known to be most beneficial? Yes. Are the dosages given too high and generally should be, titrated down? Maybe. Some kids need a lot, some kids need a little. I probably just, gained and lost a few enemies there. So the point is that these circuits are hardwired circuits.